Chapter 8, Section 6 is titled Perfect Squares. If you watched my 8.5 video where you remember what we were doing in the last section if you were in class, that 8.5 video was all about a special case with the difference of squares. Section 6 is similar in that it's another special case, but we're talking about perfect squares. So a little bit different than what we saw in the previous section, but there's kind of some basic check-offs that you want to look for first before you decide if you can factor these. When we had the same quantity being squared, and again, we did see this last chapter in chapter 7, where we were actually multiplying those out. We were using kind of our shortcuts to do this. What we're going to do now is the opposite. We're going to do the opposite of multiplying. We're going to factor these back to the same quantity that you were multiplying together. So last chapter, you would have seen something that looked like these two, where you had the same quantity squared, and there was either a minus or a plus sign in there. When you were factoring these, we had a couple of rules where we squared the first term, we squared the last term, and then we multiplied the terms together and we doubled it. That was our middle term. So those are shown here by kind of these rules, and this is what we talked about in chapter 7. What we're going to do now is go the opposite. So they're going to give you something that looks like one of these two cases, and we're trying to now go back to the beginning, like where did they start off? So when we're talking about these problems, these are called perfect square trinomials. What you would need to look for, so these are kind of things that you have to check off your list. Number one is, are a squared and b squared, are they perfect squares? We talked about perfect squares last section. I wrote out that list of numbers for you, so you can always refer back to that if you don't remember what those perfect squares are. But you're looking at the first and the last term in your example, in your problem, and you're checking to see if they're perfect squares. Your signs cannot be negative, so you can't have subtraction in terms or of the terms of a squared and b squared. So you have to make sure that when you're looking at the sign in front of the b squared, that it's a plus sign. You can't have a minus sign in front of that b squared term. It's not going to quite factor the same way here. That middle term also needs to double the product of your square roots of those two numbers. So when you look at the first and the last terms and you square root them to get back to where they started, you have to multiply them together, and it needs to double, and that needs to show up in the middle in order for this to be considered perfect squares. So let's take a look at these examples here. So I'm just going to kind of run through my checklist. For this first one, my first check is, are the a squared and the b squared perfect squares? So are these two numbers perfect squares? Am I able to square root them nicely? So if you think about when we did that in the last section, I would break the x squared apart, and the square root of 64 would be 8. So the answer to number one is yes, they are. Okay. Next one is that your sign in front of that b squared term can't be negative, and it's not. I've got a plus sign here in front of the 64, so it's not breaking that rule either. Then the middle term, this is number 3, needs to be doubled of the a times b. So if you think about, if I square root x squared, that would give me an x. If I square root 64, that would give me an 8. If I take 2 times 8 times the x, that would give me 16x. Okay, so this is a perfect square, so I should be able to say yes for my answer here. So why don't you take a minute and try to do B and C and write yes or no, and if you're saying no, tell me why. Like what happened, what went wrong when you went through the checklist. Okay, when we look at the next one, the first and last terms are perfect squares because this would square root to 6x and this would square root to 4. If we double check the middle, if we take 2 times 6x times 4, that does not equal 24x. So I actually needed that to be 48x in order for it to have been doubled. So my answer for this one should have been no. And the reason is because the middle term does not double. Okay. For part C, if you look at this, originally some of you might have thought that it was a no because you didn't see the perfect squares. I will say though, if I were to take out a 5, it would say x squared minus 2x plus 1. And now if I look at my terms, this square roots to just x, this square roots to 1. And if I take 2 times x times 1, I do get 2x. So this one should have been a yes. That one was a little bit of a tricky one just because if you didn't know to take out that 5 or you didn't maybe see that, you probably wrote no. And that's okay if you did that, I just would want you to fix it. So if that was you and you did put no down, I want you to erase that, and I want you to copy down what I have written there. Okay? So now that we've kind of talked about like what makes something a perfect square, we're going to actually start factoring them now. So we saw those examples at the start of class that I kind of showed you came from like what we did in chapter 7. What we're going to do is factor these by looking for those square roots of those terms. So we're going to still make sure that it kind of satisfies those 3 rules that I had. But then what you're going to do is take the square roots. So take the first and last terms, what you got when you square rooted them, and you're going to throw those into the parentheses, and then you're going to decide is there a plus or is there a minus sign. Okay? To do this, you're going to check to make sure that there's no like terms that need to be combined yet. So if they haven't maybe simplified the example that they're giving you, you want to do that first. 2 is to make sure that you write it in descending order. Another thing that I would maybe check for within steps 1 and 2 is there anything that you could pull out? So like on that last one, how we could take out a 5, maybe ask yourself, is there anything that we could take out? Especially if maybe you look at it and you're like, no, it doesn't look like it's going to work. See if you can pull something out to make it work. Okay? Step 3 is to check for those perfect squares. Step 4 is to check to make sure that that middle term doubles. Step 5 then is to factor it and write it correctly. And then you could always check your answer by actually multiplying it back out, and you should get back to the answer or the example that you started with. So let's take a look at this first example. I don't see any terms that I need to combine. It's already written in descending order. Remember though, another thing I said to look for, especially because some of you are looking maybe at the 2 and the 200 and you know that those aren't perfect squares. Let's see what happens though if we try to simplify this by taking out a 2, because I see that they're all even. So if I take out a 2, then I'm left with x squared minus 20x plus 100. Okay, now if I look at the x squared, if I square root that, that just becomes x. If I square root 100, that becomes 10. So they are perfect squares. Let's double check and make sure that the middle term doubled. So you're taking 2 times the x times the 10, and that does give me 20x. So it does double. So far we're looking really good. Now what we're going to do is write out our answer. You take the x and the 10. That's all you need to grab from up here. And you put that in the parentheses. And you're going to have a little squared because this is going to be the same quantity twice. This is kind of how these ones are always going to factor. And then you got to decide what sign you need. Do you need a plus sign or a minus sign? How you determine that is you look at the sign before the middle term. So before that x term. This one has a minus sign. So in here you need to have a minus sign. And this is how you're going to factor it. Again, like in the last section, this really isn't super hard once you get the hang of it. So don't try to overcomplicate these. That's kind of the biggest thing I see within this section and the last is that students try to make these a lot harder than they maybe need to be. So just try to make sure that you're thinking about it and not trying to overdo anything and then make this like a really big complicated problem. You don't want to waste your time doing something like that. On the next page here, there are 2 practice problems, this one and this one. I want you to go ahead and pause your video, try to do those 2 practice problems, and then go ahead and come back and watch and see if you got the right answer. Again, this one, when I first looked at it, doesn't look like it's going to work, but looking at the three numbers 12, 36, and 27, I can take a 3 out of all of those. And so it became 4x squared minus 12x plus 9. Then I do my checking. This is a perfect square. I could square root that to 2x. I could square root 9 to 3. The middle term, if I take 2 times 2x times 3, that does give me 12x. So again, we're checking all the boxes here. I needed to grab the 2x and the 3. That goes in the parentheses, and you have the little 2 on the outside. And the number, or the sign needs to be a minus sign in between those two terms. Now, the other thing that you want to make sure that you keep is that 3. That needs to come down here in the front because we did grab that. And now that I think about that, I think we might have forgotten to do that here. Yes, we did. So on this one, this was the example I did before you guys did your practice. I forgot to bring this 2 down because we pulled that out. That 2 needs to sit in front of those parentheses. So sorry about that. Okay, moving on to this practice problem here. I automatically see that these are perfect squares. This square roots to 5x. This square roots to 6. 2 times 5x times 6 is 60x. So then I grab the 5x and I grab the 6. That whole quantity gets squared, and you needed a plus sign in the middle of this one because that sign before the x term was a positive. And you don't have any numbers sitting in front of this one because we didn't have to take anything out in order for us to do this problem.